Hey everybody, welcome to video 2-1. In this module we're going to be talking about the different types of transformations, and the first one that we're going to encounter is a translation, as you see here in the title. Remember from the previous module when we encountered coordinate geometry and transformations that a translation is the same thing as taking a figure and sliding it in just one or two different directions around the coordinate plane or in space. So I always think of the SL right here in translation, and that goes along with the SL of a word slide. Okay, if we think of the figure sliding and look for the SL in the middle of the word there, translation, that's a reminder to us of what that does. Okay, so let's start on the next page. I'll be on page 64. And on Explain 1 here, a little further down the page, we're going to be talking about doing this translation using what's called a vector. Okay, so a vector is a quantity that has both a direction and a magnitude. It looks like just an arrow, but it's a little bit more detailed than that. It's pointed in a certain direction, and it has a certain length or magnitude. The initial point is kind of like the end point of a ray. It's the starting point of the vector, and then the terminal point is where you end up at the end of the arrow, basically, and that's the ending point. So as we name it, as you can see here, we could name it with the two letters in this diagram. E and F are the points that kind of make up the vector. So we could name it as EF, and just look at the notation there. It kind of looks like a ray, notice, but there's only 1/2 to the arrow on the end there. Again, it is important that it's ray, the same as a ray EF, and vector EF means it starts at E and goes in the direction of F, but just be careful about the notation. It's going to be just kind of a little line with only 1/2 of the arrow over the top of it. So when you see that notation, that means a vector, okay? The important thing to know about a vector is that when it's used in a translation, it is showing you what direction is a figure going to move and how far. And every single point of prime notation, as you can see here in this diagram, we had our original pre-image triangle ABC that was translated here along vector V. Notice the end triangle, or the image triangle, with our prime notation A prime, B prime, and C prime. If we were to go ahead and draw vectors that connect each of the pairs of those points, so A to A prime, C to C prime, and they've drawn one in here, as you can see, B to B prime, those vectors are going to be the same length, and they're going to be parallel to the original vector that you're being indicated of the direction you want to go. So how do we think of parallel? Well, just a reminder here that if you have vectors that are parallel, then that also means that the lines will have the same slope. So that's important when we start plunking things on the coordinate plane. Go to page 65. And in example 1, it says, draw the image of triangle ABC after a translation along vector V. There's that notation again. So as we look at our grid here, they've defined us a vector, and what we need to do is slide this original triangle ABC along the grid on that same vector. So every single point, A is going to go parallel to that vector, B is going to go parallel to that vector, and C is going to go parallel to that vector. And the way to make sure that you're doing that correctly is by thinking of parallel lines have the same slope. So what you want to do is you want to basically break down vector V, that's only supposed to have 1/2 to it, into horizontal and vertical parts. In other words, if you think of this vector as the hypotenuse of a right triangle, and we were to go ahead and sketch in the right triangle that connected those beginning and end points of the vector, it would tell you what is the horizontal motion of this vector here, and that's 1, 2, 3, 4 units to the right, and then the vertical motion of that vector is 2 units up. So you can go ahead and draw in those vectors that go over 4 and up 2, over 4 and up 2 from every single pre-image point, and that will give you, the ends of those vectors gives you where your new figure is going to be drawn. Okay, so let's fill in the blanks here a little bit. Part B, we're going to draw a vector from the vertex A that is the same length and parallel to, goes in the blank there, to vector V. The terminal point A prime will be the same distance away as the vector is. So they want to know how many units up. Well, if we go back to our vector and we count the blocks, that would be 1, 2, 3, 4, 5 blocks up. So 5 units up, and then 3 units, which way did the vector go? It went to the left, as we're thinking of left versus right. So 3 units left. So we want to do that from A. So we're going to go and count 1, 2, 3 units left, and 1, 2, 3, 4, 5 units up. If you want to draw in that point, be right about here. And if you want, you can draw in the dotted line vector that gets you there. Again, this is hard to do on the stylus, but you don't really need to draw in the vectors themselves. We're really just more interested in the ending point. So again, from D, and let me see if I can zoom in for you guys a little bit so this is a little neater. From point D, we want to do this vector from all 4 corners of the pre-image. Looks like what we have here is a trapezoid. So we're going to count over from D, 1, 2, 3, and then 5 units up. 1, 2, 3, 4, 5. So our new point here is going to go right here, and that's going to be D prime, just like this one up here was A prime. Okay. So you're going to do that with all 4 points, and you'll notice that the translation is a rigid transformation. So I'll just do this really quickly, and we're going to sketch our final trapezoid. I'll do it in red so it kind of shows up a little better. And our final trapezoid, which of course we've gone through and labeled each of the corners with our prime notation. Our final trapezoid is identical, and you are going to see that it's just moved the direction of the vector that the vector was indicating. Okay, let's go back to our fill-ins here. Like we said, we did it with 1 on point A. We're going to draw 3 more vectors that are parallel from points B, C, and D, with, of course, the corresponding terminal points B prime, C prime, and D prime, and then finally draw segments that connect all of them to form the image figure. Pretty straightforward there, okay? So again, make sure that those vectors are parallel by breaking them down into the horizontal and the vertical parts, basically the slope, the horizontal, the rise over run, if you want to think of it that way. And then you're going to go through and do that for some more examples here on the next page. I'd like you to do some your turns. I want you to do your turn number 4 and take an indication of the vector that's given to you right here as vector V, break it down into its component parts, and draw a translation of triangle ABC. So that's your turn. Take a quick pause on the video, and then we'll move on. Okay, and explain 2, what we want to do is we want to draw translations on the coordinate plane. So now we did have a grid, but now we're going to put it onto the 4-quadrant coordinate plane. Okay. Couple of things you want to highlight here, and that is component form for a vector. Notice the notation, they're square brackets instead of rounded parentheses. They're almost like angled brackets, if you will. When you see those, you know you're talking about a vector, and A and B are the number of coordinates that you would go positive up or down on B. Positive is to the right on A or to the left. So just keep that in mind. So for instance, the component form for this vector that you see over in the diagram right here, because we're going to the right 5 and up 3 both in a positive direction, we would just call that vector 5, 3, 5, 3 with those angular brackets or square brackets. Okay. So here are the up, down, left, right translation rules as you see here in our box. And remember, boxed information is what you want to draw your eye to as far as good to know and either commit to memory or make sure you study hard. Again, if A is being added to X, this is going to be an indication that we're moving to the right on the vector. If A is being subtracted from X, we're going to the left. If we take a value B and we add it to Y in our translation, then that means we're going up B units. And then if we have a minus sign there, we're going down B units. So it corresponds to the directions on the coordinate plane pretty easily. What we want to do next is just kind of walk through example 2, where we're calculating new vertices when they give us a vector in component form. Okay, so here's my vector in component form rather than actually drawing the vector on the diagram. So we have pre-image coordinates -2, 1, -3, -2, and -1, -2 along a vector 4, 6. So remember what that means again. That means to the right 4 and up 6. And what we want to do is predict which quadrant the new image will be drawn in. And if we just kind of did a quick little sketch there with a 4, 6 vector, we would predict that it would be in the first quadrant. But we're going to use a table and actually come up with the new coordinates. And again, this is +4 on X and +6 on Y. So -2 + 4 is 2. 1 + 6 is 7. And we do that for each of the points going down the line there. And then we're going to sketch it. So that's what they've done in example 2. On the next page, and I'm on page 67, you guys, this is part B, we are taking the pre-image coordinates 3, 0, 2, -2, and 4, -2 along a vector of -2, 3 in component form. So let's plot those points. First off, A is 3, 0. It's going to be right there. B is 2, -2, right there. And C is 4, -2. So we've got our original pre-image triangle. And the vector -2, 3 might be good to just remember which direction that means. -2 as an X component to the vector means we're going to the left 2. And +3 for a Y component to the vector means we are going up 3. Okay, so all of these points that we've just sketched, which are A, B, and C, are moving left 2 and up 3. So again, -2 + 3 if we were going to write that in translation, to write that translation in transformation form. Our prediction is if we're going to the left and up is that we might land in quadrant, remember 1, 2, 3, 4. I'm going to predict quadrant 2, but we'll see where that goes. We'll put a question mark by it because we have to check out the coordinates and see what happens there. Okay, so 3 is going to get 2 subtracted from it, so we land at 1. 0 is going to get 3 added to it. We land at 3. 2 subtract 2 is 0. Negative 2 add 3 is 1. And 4 subtract 2 is 2. Negative 2 add 3 is positive 1. So I'm going to change colors here so we can see the difference between image and pre-image. Pre-image is in blue. Here's my image coming out for you right now. So 3, 0 has moved. A prime is now 1, 3. B prime is 0, 1. And C prime is 2, 1. So looks like my image triangle actually is not in quadrant 2, but actually has moved just up to quadrant 1. Oops, quadrant 1. Sorry about that, you guys. 1, big fat Roman numeral 1. Alright, so I would like you to take a pause in the video and do the same thing, paying attention to the component form of the vector. For these your turn problems here, 5 and 6, you're using the same vector for each one, and that is a negative 4, 1 vector. So identify what that means as far as what you're going to do to each of the pre-image coordinates, and then make sure you sketch both the image and the pre-image. Okay? Okay, in the last part of this video, guys, we're just going to be specifying the translation vectors in Explain 3. So you're going to be seeing both the pre-image and the image, and you're going to be asked to come up with the component form for the vector, and basically looking for pairs of points, because all of the pairs of points will have taken the same motion. Okay, so here in example 3, you can see that they've connected a pair of points, in this case B and B prime. Probably makes sense to connect the one where you're not having to draw through a figure to draw the vector in. But again, you always want to start at the pre-image, so the one without the prime notation, and draw your vector to the one with the prime notation. And then again, we're just going to count the direction and the number of units that we moved. So we moved 1, 2, 3, 4, 5 to the right, and we moved 1, 2, 3, 4 down. So you can see in vector form at the end, we are taking a positive 5 because we went to the right, and a negative 4 for the y component because we went down. So that's all you really have to do in those problems when they give you both a pre-image and an image. And again, remember, you're looking to start at the one without the prime notation and go to the one that has prime notation. Or if you can see the color shift, it's sometimes a little harder to see in the black and white textbook, but you want to make sure you go from the darker one, which is the pre-image, to the lighter one, which is the image too. Alright, let's see what we have on the next page. And on this page, you guys, I'm actually going to make your turn here, part B of this example. I think you can go ahead and read through the one before and fill in. Remember to connect the pairs of points and finally end up with the component form when you're done. Okay? I will see you guys in the next time, the next video, next class, whatever the next stage happens to be. See you later.